Hi, Integrated Math 1. Welcome to lesson 4.2.1a. We're going to be creating and interpreting frequency distributions. We've mentioned frequency before, right? In the last unit, frequency got measured when we talked about when we did our histograms, right? And they're basically bar graphs, and the width of the bar was what we called the bin, like from 5 to 10 or whatever it was. And then the height of the histogram was the frequency, right? How many things are in the bin. So we're going to be playing with that a whole bunch more this unit. We're just taking it a step further as we do. So we're going to be over on the next two lessons here. We're going to construct and interpret frequency and marginal frequency distributions displayed in two-way tables for two variable categorical data. Now we're going to have two variables at play, right? Not just one anymore. We're going to create and interpret graphs of frequency distribution that are displayed in our two-way tables. Don't worry if you're a little confused on the terms. You know, we're going to talk about them. We do have a bunch of key terms: categorical data, two-way frequency table, frequency distribution, joint frequency, and marginal frequency distribution. Wow, it's a lot of terms, but we're going to be tackling those as we go throughout all of this stuff. So you've explored the relationship between two variables of numerical data, right? Comparing the numbers of two sets of data, no problem. But how can you follow the statistical process to determine whether there are any associations between two variables of categorical data? So let's see if we can get the idea of what I mean about categorical data. So in your book, toward the end of the lesson, there's a page that they want you to cut out. We're not cutting it out. We're not going to do that. We're just going to talk about this for a minute. We're going to talk about what kind of answers people would give. Like if I give out a survey with all of these questions, what kind of answers would people give, right? How many pets do you own? I own one pet. Maybe you own 0 pets. Maybe you have some dogs and cats and a turtle and whatever else, and you have like 5 pets. But my answer is always going to be a number, isn't it? But on a question like question B, what is your favorite color? Well, for me, my favorite color is purple. But you might say that your favorite color is green or your favorite color is blue. Well, that's not a numerical answer anymore, isn't it? It's what we refer to as a category, right? Some of us are purple people, some of us are green people, some of us are yellow people, right? Whatever color it is you like. And that would also apply to your favorite sport. My favorite sport, volleyball. I love volleyball. But maybe you love basketball, maybe you love football or lacrosse or running or any figure skating. I don't know, it's up to you. So again, I'm not getting a numerical answer here, I'm getting a category, right? And we could keep going through these. What score did you earn on the last math test? That'd be a numerical response, wouldn't it? How many texts do you send per day? A numerical response. What type of music do you prefer? That would be a category, wouldn't it? Not a number. How many glasses of water do you drink each day? That'd be a numerical response. How far do you live from the school in miles? That'd be a number, right? What's your favorite snack? That's a category. How many hours do you watch television per day? That'd be a number. What mascot would you prefer for a sports team? That'd be a category, right? Eagles, Bears, Bruins, Padres. What grade are you in? Also numerical answer, right? 9, 10, 11, 12, that kind of a thing. Although this one's funny because I guess you could also consider it a category, like 9th graders and 10th graders and 11th graders and 12th graders. Just saying. So 2 types of variable data that can be collected from a statistical question are what we were just talking about: numerical and categorical data. So numerical data, obviously, just to give a number for an answer, yay. Categorical data are data that can be grouped into categories, right? These people like purple, these people like green, right? You can separate them out into categories. And numerical data are data that can be placed on a numerical scale and compared, right? I could stick that sucker on a number line and I could compare it. So let's go over to page 57 in our workbooks. Miss Seymour is the school cafeteria supervisor at Williams High School, and she has been asked to cut her food budget for the upcoming school year. So one idea she has is to cut the number of meal choices during the week. So Miss Seymour decides to survey the students in Miss Colby's gym class, Mr. Colby's gym class, which consists of 9th and 10th graders, right? That's usually who's taking gym. She recorded the results of her survey on the table shown. So she recorded a grade, whether they were 9th or 10th graders, and what their favorite meal was from the cafeteria. So the first step of the statistical process is to formulate a statistical question, right? And the second step is to collect the data. So what type of collection method did Miss Seymour use? How did she get the data? Hit pause, jot down your thoughts, hit play to keep going. If you flip back, it says that she decided to survey the students. So Miss Seymour used a survey to collect a sample of the total population of 9th and 10th graders. She didn't ask the whole school. She didn't even ask all of the 9th and 10th graders. She just picked a sample of the 9th and 10th grade population. So what questions did she ask the students? Hit pause, jot down your thoughts, hit play when you're ready to keep going. So it looks like she asked them what grade they're in, right? She recorded that, 9th or 10th grade. And she also asked them what their favorite meal was. So what is your favorite meal to eat at lunch and what is your grade level? So it looks like given the data she collected, I think that's what she's got here. Can you describe the data she collected as either numerical or categorical and explain why? Hit pause, jot down your thoughts, hit play to keep going. So this is totally categorical data, right? I mean, the lunches are not numbers. The lunches are categories, right? These are the lunches that they wanted. So this is very much categorical data. It's not a number answer that we're getting here. You know, this is great. She has this lovely table. But just looking at Ms. Seymour's table, because the third step of this, so the first step is to formulate a question, to figure out how to collect your data. The second step is to collect all the data. Third step is to analyze the data. So here's Ms. Seymour's table. We'd like to analyze Ms. Seymour's table. Can you see any trends in the data just by looking at her table? And tell me why or why not. Hit pause, write it down, hit play to keep going. So, I mean, it's great that she has all this data in a table, but I'm having a hard time seeing any trends. It's a good way of recording the data, right? 9th grader, this kid's 9th grader said salad bar, that kid's a 10th grader said burgers. But it's not a good way to find a summary of the data, right? It's great to make a table to record the data. It's just not sufficient to provide a summary of her records, right? To come to some kind of conclusion. So this is great. She made her survey, she collected the data, that's awesome. But we need to analyze it. And this is not a very good way to analyze it or come to any conclusions. So we need to organize it a little bit better. So previously, we've analyzed two variable data sets that were what we call quantitative or numerical. Sometimes we call numerical data quantitative data. And we displayed them as scatter plots. We did a regression curve, right? We've done all that kind of junk before. But in this topic, we're going to explore the relationship between two variable sets that instead of being numerical are categorical, okay? This is what we've got here. By the way, categorical data can also be called qualitative data. So don't freak out if you see qualitative. That just means it's categorical. That's all we're talking about. So one method of organizing categorical data is to use a two-way frequency table, okay? A two-way frequency table displays categorical data by representing the number of occurrences that fall into each group. So we have two variables, we have all of our options, and then we just say, okay, this is how many were in this group, this is how many were in that group, this is how many were in that group. Because again, categorical data is groups. So a two-way frequency table displays our categorical data by telling us how many are in each group, okay? On the table, one variable is divided into rows and the other is divided into columns. So we're going to consider our lovely table here from Miss Seymour. I still have it on my page just for you. The first variable is the grade level, because we've got two variables. The first variable is the grade level. Real quick, can you just identify the two groups, the two categories in our grade level? Hit pause, write it down, hit play to check your work. So, of course, if our first variable is grade level, we're only dealing with 9th and 10th graders. So the groups are 9th grade and 10th grade. Our second variable is the favorite meal, right? So our first variable is the grade. Our second variable is the favorite meal. Can you write down the different categories for favorite meal? Can you just write down our groups for our favorite meals for this variable? Hit pause, write it down, hit play to check your work. So the four groups I see salad bar, I see burgers, I see pizza, I see chicken nuggets. Yeah, and then it just repeats. So salad bar, burgers, chicken nuggets, and pizza. Awesome. So we've identified our categories, we've identified our variables, and then we've identified our groups within our variables. All right. So we've got a variable of grade, 9th or 10th. We've got a variable of favorite meal, which is salad bar, burgers, chicken nuggets, pizza. Hey. So the third step is to analyze the data numerically and graphically. So what we're going to do is we're going to create a two-way frequency table to help us organize our data so that we can analyze it numerically. So on page 60, 4-60, you're going to create a two-way frequency table, and they have this lovely table here for you. First thing I want you to do is just fill in the green bits on this table. Can you fill in what the grade levels are? Fill in what your favorite meals are. Hit pause, fill it in, hit play to keep going. So we said for grade level, it was 9th grade or 10th grade, one of the two. We said for meals, and my order might be a little different than yours. Don't panic, it's okay. For meals, we said we had burgers, we had chicken nuggets, we had pizza, and we had salad bar. So I'm just going to put all those in. If your order is different, don't panic. It's okay. This will still work out all right. Now, what we're going to do is we're going to fill in this table. And all we're going to do is we're just going to make tally marks, right? So like I see for the very first one, grab my pen here. I see for the very first one, I have a 9th grader who likes the salad bar. So a 9th grader likes the salad bar. Boom. I'm just going to put a little mark there. A 10th grader who likes burgers. 10th grader likes burgers. Boom. Put a little mark there. Keep going, put in all the little marks, and then count up your tally marks for each group, okay? Hit pause, fill in the table, hit play when you're ready to check your work. All right, so I'm gonna fill this in. We got a 10th grader who likes pizza. We've got a 10th grader who likes chicken nuggets. Another 10th grader likes chicken nuggets. A 9th grader who likes burgers. A 10th grader who likes the salad bar. 9th grader who likes the salad bar. 10th grader who likes chicken nuggets, 9th grader who likes burgers, 10th grader who likes pizza, 9th grader who likes a salad bar. You may have to keep your finger on the table as you go, it'll help. 9th grader who likes burgers, a 10th grader who likes burgers, a 9th grader who likes chicken nuggets, 9th grader who likes the salad bar, a 10th grader who likes chicken nuggets, another 10th grader likes chicken nuggets. I group in 5, so I put that slash across for the 5th one. 10th grader likes the salad bar. 10th grader likes burgers. Another 10th grader likes the salad bar. A 9th grader likes burgers. A 9th grader likes pizza. A 10th grader who likes chicken nuggets. Wow. 10th grader likes the salad bar. 9th grader likes the salad bar. A 10th grader likes pizza, a 9th grader who likes pizza. Sorry, that went wonky. A 10th grader likes pizza. Another 9th grader likes pizza. A 10th grader who likes chicken nuggets, and a 9th grader who likes pizza. Sorry, that went a little weird. So if we count all these up, I've got 4, 1, 4, 5, 3, 7, 4, and 4. So hang on, I'm going to bring in all my numbers here. Sorry, I must have miscounted. I accidentally counted somebody extra. I'm sorry. There, is that better? All right, so we filled in our table. You may want to double check. I do know that these numbers are right. I did double check that. So 4, 1, 3, 5, 3, 7, 3, and 4. Looks like I just got an extra pizza in there. and an extra pizza up there too. Wow, why am I doing extra pizza? There, that's better. So it can be hard to do this. Again, this is a matter of organization. You might want to like trace your finger along her data table as you make your marks in there, because you can see how easy it is to make mistakes. Now that we have this, yay. Kind of glancing at it, do you see any associations between grade level and favorite meal? And if so, what trends do you think exist? Hit pause, write down what you notice, hit play when you're ready to check your work. So I'm noticing that the 9th graders seem to like the salad bar best, and that the 10th graders seem to like the chicken nuggets best. So most 9th graders prefer the salad bar, and they really don't seem to be into the chicken nuggets. And for my 10th graders, they seem to be really into the chicken nuggets. Seem pretty indifferent about the rest of them. So this table that we just created is called a frequency distribution table. It's a two-way frequency distribution table because I have two variables, two categorical variables that we did. And remember, frequency is just how many are in each group. So we made a two-way frequency distribution table. Yay. A frequency distribution displays the frequencies for categorical data in a two-way table. Each time you determine the frequency of one favorite meal of one of the grade levels, you recorded a joint frequency. So remember how we said, oh, the 9th graders like salad bar best. That's a joint frequency because we joined those two categories, right? We said 10th graders like chicken nuggets best. That's a joint frequency because we joined those two categories. So any frequency you record within the body of a two-way frequency table is a joint frequency. So this 7 is a joint frequency between chicken nuggets and 10th graders, right? This 5 is a joint between 9th graders and the salad bar. So it's a joint frequency. It joins together our two variables. So a two-way frequency table is helpful in organizing each group's frequency in an effective way, right? I can easily see how many fall into each group. However, it is common to determine the total number of people surveyed just to ensure a good survey was taken, right? Because we didn't ask all the 9th and 10th graders. We just asked some of them. So it's good to know the total number of people that you surveyed just to make sure you got good data. Determining this is also helpful to ensure that you recorded your data accurately within the table. So for example, if you know 50 people took part in the survey, but when you add up all your joint frequencies, you only get 47, then you know that you're missing a couple data points from your data set. You know you missed something. Go back and check, right? So here's what you're going to do. I would like you to use the data from your frequency distribution to determine the total number of 9th graders, the total number of 10th graders, and the total number of frequencies for each category. So you're just going to add, give me the total, 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 add, give me the total. And even down here, you're going to add these to get the total here, and you're going to add these to get the total here. You get the idea? Go ahead, hit pause, fill in your table, hit play when you're ready to check your work. First of all, I'm going to fill it in with our data from the last table, right? We said 4 9th graders preferred burgers, 1 preferred chicken nuggets, 3 preferred pizza, and 5 preferred salad bar. And with our 10th graders, 3 of them preferred burgers, 7 of them preferred chicken nuggets, 3 preferred pizza, and 4 preferred the salad bar. So I'm just filling this in from last time. And now I'm just going to grab a calculator. I'm just going to add, right? 4 plus 1 plus 3 plus 5. Actually, you know what? I'm going to add this way first. 4, it's easier. I don't need a calculator. 4 plus 3 is 7 total preferred burgers. 1 plus 7 is 8 people that prefer chicken nuggets. 3 plus 3 is 6. 5 plus 4 is 9. All right, then. All right, then. And then we'll add across. Total number of 9th graders. 4 plus 1 plus 3 plus 5 is 13. 3 plus 7 plus 3 plus 4 is 17. Now, let's figure out the total number of students we surveyed. If I do 13 plus 17, I get 30. But I want to double check, so I'm going to add across this way as well. 7 plus 8 plus 6 plus 9, use my calculator. I still get 30. Okay, good. So these numbers all match up, right? I add these up, I get 30. I add these up, I get 30. So it looks like we surveyed a total of 30 students. Awesome. We just created a marginal frequency distribution. I know, so many terms. We just created a marginal frequency distribution of the data because we determined the totals for each group, right? The moment I added them up, I created a marginal frequency distribution. So marginal frequency distribution displays the totals of our frequencies, all right? It displays the totals of our rows, totals of our columns, and of course our total overall. So that's when it becomes a marginal frequency distribution. I've now displayed all my totals. So this is really useful. On page 61, on number 6, I have a whole bunch of questions for you. A, B, C, D, I got a whole bunch of these. Can you answer all of these lovely questions now that you have your distribution, your marginal frequency distribution table? Hit pause, answer all the questions, hit play to check your work. So how many ninth graders participated in the survey? 13 ninth graders participated in the survey. How many students preferred burgers? Oh, we got a total of 7 students that prefer burgers. How many students preferred chicken nuggets? I got a total of 8 students that prefer chicken nuggets. How many 10th graders participated in the survey? Looks like I've got 17 total, so 17 10th graders participated in the survey. How many students preferred the salad bar? I would say 9 of them did. And which meal did the least number of students say was their favorite? Well, I'm looking at these totals, and it looks like the pizza was the least favorite. Which meal did the least number of ninth graders say was their favorite? Wow, chicken nuggets, right? And those ninth graders, if I'm looking at my ninth grade row, they were not digging on the chicken nuggets. Which meal is the most favorite of all the students? Well, we look down here as our totals. Looks like the favorite meal was a salad bar. Which meal was the most favorite of just the 10th graders? Well, here's your 10th grade line. Ooh, chicken nuggets. They do dig their chicken nuggets. Awesome. So I love this marginal frequency distribution table. Super easy to answer a whole bunch of questions. Much easier than the original data where the original data was recorded. So it's just great. We have it organized. We can easily answer questions about it now. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, email me, come talk to me. I'm around at break and lunch and all that good stuff. And I'll see you guys soon. Bye.